The rectangular coordinate system, that is going to be the topic for our discussion. Okay, so the rectangular coordinate system, or others call that one the Cartesian coordinate system or the Descartes coordinate system. Okay, so it is composed of the x-axis. So suppose you have this one, uh, having the points -8 to +8, and the y-axis. Okay, so this is your x-axis, so that's the one I told you. This is the y-axis, and the 0 is the intersection of the x and the y-axis is called the origin, and we denote that with 0. Okay, so the rectangular coordinate system is divided into 4 quadrants, quadrant 1, 2, 3, and 4 in a counterclockwise motion. Okay, so in quadrant 1, you will have all positive values for x and y. Quadrant 2 has negative x and positive y. Quadrant 3 has negative x and negative y, while quadrant 4 is uh, having a positive x and a negative y. So for example, if we are going to plot the points, okay, so the ordered pair xy in each of the quadrants. So if we are given point A, okay, point A has the coordinates 5, 3, so it is found on quadrant 1. Then we have another point B. Okay, it has the coordinates 2, -1, so it is therefore in the quadrant 4. And if we have the point C, having the coordinates -2, -3, so it is in the quadrant 3. And if we have the point D with coordinates -4 and 2, so that is in quadrant number 2. Okay, so plotting points is very easy. So we have done that in the algebra, the basic part in algebra. So this is just a short review. Okay, so plotting points is very easy. All you need to do is to remember the signs for each of the quadrants. But then the next thing that we are going to do is, what if there is one missing? So in the ordered pair, there is one missing. Suppose x is missing or y is missing. So we do the completing of the ordered pair. So for example, if you would like to complete the ordered pair for the equation 3x plus 4y equals 7 and given 5x and a known y, so what we need to do is we will substitute the given x equals to 5 to the equation 3x plus 4y equals 7. Thus, we have 3 times 5 plus 4y equals 7. So that is 15 plus 4y equals 7, or you have 4y as 7 minus 15, or 4y equals -8, so y equals -2. So the ordered pairs now is 5, -2. Okay, so what if you are given the y, which is -5, and you are going to, in the same manner, we're talking here of linear equations. Okay, so in two variables. So if you notice in the previous example that we have two variables, x and y. Okay, so when we say linear equations, that is in a form of ax plus by equals c. That is a linear equation in two variables, where a, b, and c are real numbers, and a and b are not both 0. Okay, so that form ax plus by equals c is called the standard form. Okay, so in relation to this one is the finding of the intercepts. Okay, so when we say intercepts, those are the points that intersect either the x-axis, or called the x-intercept, or the point that touches the y-axis, or called the y-intercept. Okay, so finding for the intercept, okay, because that is useful when we are going to graph a line. Okay, so the easiest way to graph a line is finding for the intercepts, or the x and the y intercept. So how will we do that? Okay, so in finding the intercepts when graphing the equation of a line, the first thing is you're going to let y be 0 and find x. You call that one finding for the x intercept. Or you let x be 0 to find the y intercept. Okay, so for example, you are given the equation 2x minus y equals 6, and you are going to graph that equation in the rectangular coordinate system. So you need to have 2 points, and that is the x and the y intercept. Remember, in geometry, 2 points determine a line, so we only need 2 points, the x and the y intercepts, in order to graph the equation 2x minus y equals 6. So the first thing that we do is we find the x-intercept by letting y be 0. So from the equation 2x minus y equals 6, substituting y equals to 0, so you have 2x minus 0 equals 6, and you have 2x equals 6, or x is equal to 3. So now you have the point 3, 0, and your x-intercept is equal to 3. So the point we have is 3, 0. Next is we are going to find for the y-intercept. So let x be equal to 0. Go back to the equation 2x minus y equals 6. So substituting x be 0. So you have negative y equals 6. So y equals negative 6. And you have the y-intercept 0, negative 6. Then graph it in the Cartesian plane. Okay, so first we have the 2 points, 3, 0, and 0, negative 6. So 3, 0 is there. Okay, then we have 0, negative 6 in the, yeah, it's there. So connecting the 2 points, we have the line, the graph of the 2x minus y equals 6. Now, the next thing we are going to do is graphing the horizontal and the vertical lines, because sometimes graphing the horizontal and vertical lines is somewhat tricky for some students. So, for example, we are told to graph y equals negative 3. Okay, so it is understood that whatever values of x that you are going to assign, the y is constant at negative 3. Okay, so suppose we will have assigned 2, then y is always negative 3. Then we have 0, negative 3, or negative 2, negative 3. So we have the 3 points. So plotting these 3 points in the rectangular coordinate system, okay, notice you have there the graph of the line y equals negative 3. Or simply, you will simply locate where is y equals negative 3 located, and then draw a horizontal line passing at y equals negative 3. Okay, so next is the vertical line. Suppose you are given that equation x plus 2 equals 5. You have to simplify that first. So you have x equals 3. Okay, so when we say x equals 3, whatever y that you are going to assign, x is always constant at 3. So simply, without you may even have to show 3 points. You have 3, 2, 3, 0, 3, negative 2. So if you plot that, okay, so notice that it is the vertical line that passes through the point x equals 3. Okay, so just some word of caution. Okay, so to avoid confusing equations of horizontal and vertical lines, you have to remember that an equation with only the variable x will always intersect the x-axis, and thus it will be vertical. While for the equation that only have the y variable, it will always intersect the y-axis. That's why it is horizontal. Okay, so next is graphing a line that passes through the origin. Okay, so suppose we have the line 3x plus y equals 0. So again, if we are going to graph it, then we are going to find for the x and the y intercepts. So let y be 0 and find for x. So 3x plus 0 equals 0. So your 3x equals 0. Therefore, your x is 0. So it is the coordinates is 0, 0. Then if we are going to find for the y-intercept, so we let x be 0, so that is simply y equals 0. So we have the point 0, 0, and both the intercepts are the same ordered pair 0, 0, which is the coordinate of the origin. Okay, so this means that both the graph passes through the origin. So it's the 0, 0. Okay, so to graph that one, although we know that it passes through the origin, so what we need to do is we are going to find for a non-zero value for x and solve for y. Okay, suppose we let x be equal to 2, so we have 3x plus y equals 0. So 3 times 2 plus y equals 0, so you have y equals negative 6. So we have the ordered pair 2, negative 6. So we have another point that is a non-zero, so it's 2, negative 6. So we already have the origin, the 0, 0, so we can graph it on the Cartesian plane or in the rectangular coordinate system. So we have the first point 0, 0, the x and the y intercept, and we have the next point uh, 2, negative 6. So that is the second point. So drawing a line that passes through the points, that is, we have the graph now of the equation 3x plus y equals 0. Okay, so you can always check, also you can always verify is if 1, negative 3 also lies on the same line, or you can assign any point, okay, to verify whether there is a point that lie on that line. Okay, so now we are down to the lesson which is related to the rectangular coordinate system, the ordered pairs. Okay, the next thing is finding the midpoint of the line segment. Okay, so when we are going to find the coordinates of the midpoint, okay, so we know that the midpoint is the one that divides the line segment into two equal parts, so that when we are going to find for the coordinates of the midpoint of the line, we need to add the x's, okay, so both ends, so x1 plus x2, then we divide it by 2, then divide the y's, get the average of the y's, so you have y1 plus y2 over 2. So that is the formula of finding the coordinates of the midpoint of a line segment. Okay, so for example, you are asked to find the coordinates of the midpoint of the line segment PQ having the endpoints P, coordinate 6, negative 1, and Q, coordinate 4, negative 2. So, using the midpoint formula, okay, so we know that x1 is 6, x2 is 4, negative y1 is negative 1, and y2 is negative 2. So, that we have 6 plus 4 over 2 and negative 1 plus negative 2 over 2, or simplifying, we have 10 over 2 and 3 negative 2 as your y. Then we have 5 negative 3 halves. Okay, so that ends our lesson on the rectangular coordinate system. Find for x. For the same equation, 3x plus 4y equals 7. So what you will do is simply substitute again the negative 5, okay, to the equation 3x plus 4y equals 7. So you have 3x plus 4 times negative 5 equals 7. And so you have 3x minus 20 equals 7. And you have 3x equals 27. Or x equals 9. Okay, so now we have the ordered pair 9, negative 5. Okay, so completing ordered pairs is just so easy. All you need to do is you are going to substitute the given uh, to the equation and find for the unknown. Okay, so